Hey guys, in this lesson we would talk about instantaneous rate of change. We already know instantaneous rate of change is IROC, and this is the slope or rate of change at one given point. That's why the name is instantaneous, because it's at one particular instant. IROC, we would be given two types of questions. One is from the graphs and one is in the form of equations. Graphs can be given in two forms: linear graphs, same way as we did in IROC, and nonlinear graphs. Equations can be given in the form of word problems or direct equations. However, for solving IROC, when we are given equations, there are three different methods to do so. One is called centered interval, one is called preceding and following interval, and the other is called difference quotient. We can represent these with acronyms. So centered interval is CI, preceding interval, following interval can be represented as PI/FI method, and difference quotient can be represented as DQ method. We will be taking up all of these methods one by one. Let's first talk about graphical questions. If let's say we are given a linear graph and we are asked to find out IROC at x equal to 2, because IROC is supposed to be at one point, so we will always be given at one value of x. Now IROC also means slope, same as IROC, and we know slope formula is y2 minus y1 over x2 minus x1. However, here there is a problem because we are not given the other x value. But that problem is not when it comes to linear graphs, because for linear graphs, no matter if you're asked to find the slope at one point or if you're asked to find the slope between 2 points, both these slopes are going to be equal, because a linear graph has just one slope. No matter you pick 2 points, no matter which 2 points you pick, no matter you pick 1 point, slope is always going to be same for one line. Therefore, when it comes to linear graph IROC, and they have given you a point, let's say x equal to 2, we can read any other point that we can read easily. So let's say we can read 4 here, where y is 6, x is 2, y is 4. So all we have to do is apply y2 minus y1 over x2 minus x1. y2 is 6, y1 is 4, x2 is 4, and x1 is 2. We get 2 over 2, which is equal to 1. We would have done the same thing if we were supposed to find out IROC. Therefore, IROC is same as IROC in linear graphs. So for linear graphs, there is nothing different in order to find out IROC when compared to IROC. Let's move on to nonlinear graphs, and we are given a question where we're supposed to find out IROC at x equal to, let's say, 3. If this is representing time in seconds, we can say 3 seconds, and let's say this represents height in meters. Now because we have to find out IROC at x equal to 3, we'll mark the point on the graph. Now what are we going to do is, we are going to use a ruler and we are going to make a line that is going to touch the graph at point x equal to 3. It is not going to cross the graph, it is just going to touch the graph. So you will not be making a line going like this or like this. No, these are all wrong lines. The correct line is a line that is passing through the dot at one point, and this line just touches the graph at that point. This line is called tangent line. Now as we learned in IROC, that IROC is equal to slope of the second line. Similarly, IROC is equal to slope of tangent line. So in order to find out IROC, we will find out the slope of tangent line. We can read any 2 points on this tangent line that we can read properly. Let's say this is 1 point for which x is 4 and even y is 4, and this point where x is 2 and y is 0. So we know x1 is 2 and y1 is 0. x2 is 4 and y2 is 4 as well. So the points that we are reading are these, and now all we have to do is just apply the slope formula. We have y2 minus y1 over x2 minus x1. y2 is 4 minus 0. x2 is 4 minus 2, so we get 4 over 2, which is equal to 2. Now what we did is, we found out the slope of this line. Because this line passes through the curve at this point, automatically we get the slope of this curve at x equal to 3. So if we want to write on the units, this is 2 meters per second. We would say IROC at x equal to 3 seconds is 2 meters per second. And this is how we find out IROC. When we are given a nonlinear graph, the first step is to make a tangent through the given point and then pick any 2 points on the tangent to find out the slope of the tangent line. That tangent line slope will automatically give us the slope of the curve at that given point because the tangent is passing through the curve at that point. Let's say we're supposed to find out IROC at x equal to 2. Then we would make a line passing through the graph touching at x equal to 2. We see this is the minimum point on the graph. So when we make a tangent line, it would be always a flat line or a horizontal line. Similarly, if we had a graph that has a maxima, and let's say the maxima lies at 2 again, and we are supposed to find out IROC at x equal to 2 in this case as well. We know this is a maxima point. When we make a tangent passing through this point, it will again be a horizontal line. So when the tangents are horizontal lines, we know slope of a horizontal line is equal to 0. Therefore, we can conclude that at max or min point, slope is 0. But we're talking about which slope here. Specifically, we have to mention that this is IROC is 0 because the slope of tangent is 0 and slope of tangent is IROC. Now let's see if we're given the question in the form of equations, and the equation that we have is ft equal to 3t square minus 5t. We discussed this earlier that this can be done through 3 ways. One is centered interval, one is preceding following interval, and one is difference quotient. So let's go over each method one by one. Let's first take up centered interval, and the question wants us to find out IROC at t equal to 5. Let's say time is in seconds and ft is in meters. So how do we do the centered interval? Because we know IROC is same as slope. So for finding slope, we always need 2 points. So what we would do is we would keep this t equal to 5 seconds right in the middle. So we will keep it in the center and we will take one x value before it and one x value after it. The value that we are going to take before it and after it will be equidistant from this value. So let's say if we take 4.9, we would have to take 5.1 here because this is 0.1 less, this is going to be 0.1 more. If we take 4.5, this would be 5.5 and so on. Now what are we going to do is, we've got our x values. To find out the slope, we would find out our y values. So to find out y value, we would find out f of 4.9. We would sub in this equation 4.9 in place of t. The result that we would get is 72.03 minus 24.5. That gives us 47.53. Similarly, we can get our y2 value, that is f of 5.1. In place of t, we would sub in 5.1 now, and when we put it on the calculator, we'll get 78.03 minus 25.5, which is equal to 52.53. Now we would apply the slope formula to this, and we would do y2 minus y1 over x2 minus x1. y2 is 52.53 minus y1 is 47.53 over x2 is 5.1 minus x1 is 4.9. When we put this on the calculator, we'll get 5 divided by 0.2, that is equal to 25. Because this is our rate of change, so we would put meters per second as a unit. Therefore, the answer is 25 meters per second. This is how we solve the question using centered interval. The same question can be solved using preceding interval and following interval method. When the question is assigned where we have to find out IROC and nothing is specified which method to use, any of these 3 methods can be adopted. However, as specified that difference quotient is required or centered interval is required, then we have to use that method specifically. So let's learn what is PIFI method. We have the same question where we are given ft is equal to 3t square minus 5t, and we have to find out IROC at t equal to 5 seconds. Now what this preceding and following interval method means, that we would be finding the slope for preceding interval and we would be finding the slope for following interval, and we would take their average. That would give us the IROC at given point. So slope for preceding interval plus slope for following interval divided by 2 is how we find out the average. But for that, we first have to find out the slope for preceding interval, then we have to find out the slope for following interval, and then we have to add them up. So let's see how to do that. Slope for preceding interval is, if you're given time is 5 seconds, the x1 value would be a value before 5. Let's say we pick 4.9. We always try to be close to the given number. X2 in this case will definitely be 5. And if we want to find out slope for following interval, time is still 5 seconds because your IROC is for 5 seconds. Then the X1 value is going to be 5. However, the X2 value will be 5.1. Make sure if this is 0.1 less, this has to be 0.1 more only. Now we would use these values to find the y1 and y2. So this is f of 4.9. and this is f of 5. We already found out f of 4.9 in the previous centered interval work. That was 47.53. We can find out f of 5 by subbing in 5 in t. So we have 3 5 square minus 5 times 5, which is 25 times 3 is 75 minus 25, and this gives us a 50. Now we would calculate the slope of preceding interval. So slope is y2 minus y1 divided by x2 minus x1. y2 is 50 minus y1 is 47.53 divided by 5 minus 4.9. That would give us 2.47 divided by 0.1, which is equal to 24.7. Similarly, we can find out the slope for following interval. So y1 is equal to f of 5, and here y2 is equal to f of 5.1. f of 5 we already found here was 50, we can use that. And f of 5.1 we found out for centered interval work, and that was 52.53. Now to find out slope, we would do y2 minus y1, 52.53 minus 50 divided by x2 minus x1, and that would give us 2.53 divided by 0.1, which is equal to 25.3. We know the formula for the final IROC is slope of preceding interval plus slope of following interval divided by 2, and that is equal to 25 meters per second. You would notice that the answer from here and the answer from here are same, and that's supposed to be same because we are finding the IROC for the same equation at the same time. It's just that we're using different methods. You just need to know these methods. However, you can adopt any one of the methods, be it centered interval, preceding following interval, or difference quotient. However, difference quotient is the most important method that definitely we need to know how to do it. But some equations, it's hard to apply difference quotient. That's why out of centered interval or preceding and following interval, one of the methods can be adopted that can be used for any equation. Let's learn how to do difference quotient on the same question at the same time. The equation that we were given is ft equal to 3t square minus 5t, and we're supposed to find out IROC at t equal to 5 seconds. Now difference quotient has a formula, and the formula is f of a plus h minus f of a divided by h. This is the most important method to find out IROC. A is always the value for which we are looking for IROC. In this case, A is equal to 5 because we are calculating IROC for 5 seconds. The role of H we will discuss at the end. Now to apply DQ formula, we need to solve for f of A plus H, then we need to solve for f of A, then we have to subtract them and divide them by H. Now let's see how to find out f of a plus h. We know a is 5, so we can put in a as 5 here. So basically we are looking for f of 5 plus h. In place of t, we would substitute 5 plus h. How do we solve this is we would write it down 2 times and we can use distributive property. So when we multiply all this, we would be able to get 25 plus 10h plus h square minus we multiply this, we get a 25. And when we multiply this, we get a minus 5h. When we multiply this, we get a 75 plus 30h plus 3h square minus 25 minus 5h. We can collect the like terms, so we can put 3h square plus 30h minus 5h is plus 25h. 75 minus 25 is a plus 50. So this is our simplified equation for f of a plus h. Next we find out the value of f of a. F of a is nothing but f of 5. We already calculated the value of f of 5 here, and that was equal to 50. So this is going to be equal to 50. Now always remember the constant term that we get for f of a plus h and the value of f of a. If they are same, that means the calculations are correct. Now when we apply difference quotient formula, we have f of a plus h minus f of a divided by h. F of a plus h is this equation, which is 3h square plus 25h plus 50 minus f of a is just 50 divided by h. 50 minus 50 gets cancelled. We are left with 3h square plus 25h over h. Our goal is to get rid of this denominator h, and we can only get rid of this denominator h if these numbers get cancelled out. That's why I said that the constant value here and the value here should be same. Now we can factor h out from the numerator, so we'll be left with 3h plus 25 divided by h. This h and this h gets cancelled. The DQ equation that we have finally got is 3h plus 25. To find out IROC, what we would do is we would consider h equal to a plus 0.1 and solve for it, which is going to be equal to 25.3. And then we would consider h equal to a negative 0.1, and that would be equal to negative 0.1 plus 25, which is 24.7. The final IROC is the average of these two values, which is equal to 25.3 plus 24.7 divided by 2, and that is equal to 25, and that is equal to 25 meters per second. This is how we get IROC using DQ method.